All right, class. So we are now going to begin the 7.2a lesson. It is on absolute value functions. This is definitely something that we need to be comfortable with. I know we have some familiarity with the idea of what an absolute value is. Remember that the absolute value is the distance the number is from zero. So if you look at number or -4 class, -4 is 4 units away from zero, right? On the number line, -4 would be 4 units away. So just remember that distance is always positive, even though the actual number itself is a negative number. Okay, so the absolute value is distance, and for that reason, distance is always positive, and um, you will see a certain shape when we graph today. So just try your best to pay attention, try your best to write down some notes, follow along if you want with a sheet of paper. It says use the equation y equals absolute value of x to complete the following. Okay, so we know that -4, if you plug it into here, you get 4. Now, here technically, they can have two different values. You can have -1, and it could be 1. So I'm just going to write that. 0 is still 0. 1 is actually 1. And then 4 is 4. Now, it's important that we realize and we understand that absolute value functions still follow the important rule where every input has exactly one output, right? This whole module is talking about functions, and in this case class, absolute value functions do satisfy this important requirement. Okay, so if I were to map, I would just go like this, and you would see that it's right. So yeah, they do have the same output sometimes, but that's expected, right? Now maybe I shouldn't have been, doubled. Um, I guess the point of this was to show that they could have the same output, and I guess I should have just included 0, 1, and 4, right? And they would have had all the same output. So kind of messed up on that. But yeah, this still satisfies the every input has one output. Okay. Um, and you can kind of see that y equals absolute value of x would have looked like 0, 0, 1, 1, 2, 2. It would have been linear and pretty much y equals x the whole entire time. But instead, the negative portion of the graph was reflected back to its positive, right? It should have been right here, the y equals x line, but it actually curves or shoots straight back up, and it creates that V shape, right? And that's an indication that it is indeed absolute value. Absolute value functions always have the V shape. So why? Why does it have the V shape? Right? Y equals x should have looked like this, right? But this portion got flipped right there. So the reason why it has the V shape is the negative output values of the original function all flip to the positive value for absolute functions. So all these negative outputs that were supposed to be negative were all flipped to its positive, opposite value, right? But is this equation still a function? Well, does every input still have one output? Right. Some of us may also know something that we call the vertical line test, which I'm going to write right here. The vertical line test is when you take a vertical line and you just slice the graph many times, you're seeing how many times does the vertical line touch the graph. And every single time, it only touches the graph once. So that's the vertical line test. It proves that every x value only has one y value. So is the equation a function? Yes. Every x value, the input, has exactly one y value, the output. Every input only has one output. Okay, now obviously class, we started with a very, very simple absolute value function where we didn't have anything affecting the slope at all. It was just a normal y equals x. Notice how we also did not have a y-intercept. We know that a y-intercept would shift the entire graph, right? So there are so many things that we could talk about to affect and manipulate the original, and that's what we're going to do in number 2. So number 2, the graphs of y equals absolute value of x and y equals 1/2 absolute value of x minus 2 are shown below. So before we even begin, I want us to identify that there's certain things in this one that kind of make it different, right? Now, if we were looking at the two graphs currently, you can tell that the y equals absolute value of x is that v where it's just the slope is 1/1 every time, right? You can tell that this is exactly what we're used to seeing, where it's just increasing by 1 every time. The slope is 1/1. Here we can see that the second v right here, which is y equals 1/2 absolute value of x minus 2, we could see that the slope is actually 1/2, right? So it's a little flatter than usual. And we could also see that the v, the vertex, where the two kind of lines meet at this point, is no longer at 0, 0, right? It's actually at 2, 0. And it's not a coincidence that that value is where the vertex is, okay? So explain in words how the graphs are similar. I think it's obvious, class. Both graphs have a V shape because they are both absolute value functions. Now explain why they are different. Let's call this the first graph. Let's call this the second graph. The second function is flatter because of the value in front, and its vertex is not at the origin. Right? That's really important because the vertex was shifted. Okay, so these kind of manipulations, class, these kind of things that we do to affect the original function is what we call a transformation. Okay, there are many things you can do to affect the original function. You can change the slope like we did here. You can also change where the vertex is and shift. You can shift it horizontally, as you can see here. This was a horizontal shift. But we also know that if you added a constant at the end, that would start to shift things vertically, right? So this is a horizontal shift. We obviously can affect things vertically too. Okay, so how is y equals 1/2 x minus 2 shifted from y equals absolute value of x? The 1/2, the value in front, affects the steepness. We kind of should have realized that. And then the value within the absolute value bars, shift the graph horizontally. Not vertically, right? Horizontally. because it's within the grouping of X. Okay. The more you practice, the more you observe, the more you just try to see how these transformations occur, the more comfortable you will be with this. Okay, so there are a lot of examples. I'm trying to decide which examples are the best. For sure, I want to talk about the chart on page 30, but I think in the interest of time, I'm going to skip all the way to number 9 right now. So we went from 2, I'm going to skip all the way to number 9. Hmm. Okay. Well, actually, I'm actually going to go back to number 4. I want to talk about this very, very briefly. We don't have that much time. We don't have unlimited time, unfortunately. And obviously, if you want to talk study these more in depth, you should, and I definitely recommend it. But in the interest of time, we don't have all the time we would normally have. So I just want to talk about this very quickly. If you have a negative in front of your absolute value, you can already tell that it doesn't affect the original outputs. Or the output calculation would still be the same, but then you just attach a negative at the end. So I just want to be very, very clear, right? Y equals absolute value of x and y equals absolute value of negative absolute value. Y equals negative absolute value of x. The negative now makes all of the positive outputs negative. Okay, so if the original, let's say the original was y equals absolute value of x, which is like this, that V shape that we're used to seeing. Well, what if I attach a negative in front? Right, let's call this equation 1. If I attach a negative in front, class, then you know that everything that it used to be, all these values that it used to be in the positive world, are now negative. So just like a line can go from positive to negative, an absolute value function could easily go from positive to negative if you just manipulate it by putting a negative in front. Okay. So yeah. So if I were to finish this very quickly, the original would be 41014, and just by putting a negative in the front of the absolute value, you now have to change all of these outputs to their negatives. So you might be like, what, Mr. Quo? I thought you said all absolute value functions had to be positive. Yes, well, that's assuming that there is no negative sign in front of it, right? The absolute value bars will always be positive, but if you attach a negative in front of it, it of course will be negative. Everything else, everything will be affected. Okay. Yeah. So this lesson is kind of long. You want to pick and choose, but I think I'm going to stop for now. This will be part 1 of the video, and I am going to shift gears to page 30 on the student edition. Okay. Let's take a break, and I will see you guys soon.